The era opens with cold light over laboratories, server rooms, test tracks, and boardrooms where nobody sleeps enough. Steel and code move in parallel, but not at the same speed. One current is the heavy rhythm of factories, supply chains, and the physical discipline of manufacturing. Another current is the restless pulse of ideas that appear first as sketches, then as patents, then as industries that did not exist a moment earlier. The United States enters this period carrying both burdens at once. It must defend industrial weight while also surviving a faster and less forgiving innovation race that spills far beyond automobiles. In 2000, the draft of the Human Genome Project is announced, and the signal is unmistakable. Biology is becoming engineering. The ground shifts under medicine, agriculture, and data science all at once. In 2001, Wikipedia launches and rewires how knowledge circulates across borders. In 2002, the first Roomba reaches mass buyers and quietly normalizes household robotics. In 2003, the Genome Project is declared complete, turning years of scientific ambition into a new baseline for biotechnology. By the time Facebook appears in 2004 and YouTube in 2005, the atmosphere changes from simple digitization to platform acceleration. The United States is not moving through one industry cycle. It is walking into a systemic transformation. During these same years, pressure builds from every side. Japan and Germany remain disciplined industrial powers with deep engineering memory. South Korea advances with speed and confidence. China gathers scale with extraordinary momentum, learning, adapting, and expanding capacity at a pace that changes global expectations. India strengthens its own long game, and the wider field, from France and the United Kingdom to Canada and Mexico, keeps competing through specialization, integration, and institutional stamina. There is no empty lane in this race. Every gain must be earned against serious rivals. In 2006, Amazon Web Services expands with foundational cloud services and gives companies a new way to build without owning everything. In 2007, the first iPhone reframes software, hardware, and daily behavior in a single stroke. In 2008, SpaceX reaches orbit with a privately developed liquid-fueled rocket and makes commercial space feel immediate rather than distant. Then, in 2009, financial shock tears through the global system. Factories slow, confidence drops, and decision-makers are forced to choose between panic and reinvention. The American Recovery and Reinvestment Act channels large public support toward research, broadband, and clean technology. And that choice matters, because crisis years often decide who still has strategic options later. From 2010 onward, the competition becomes more complex and less forgiving. Instagram appears and extends the mobile era into culture, advertising, and global communication habits. In 2011, IBM Watson defeats Jeopardy champions and turns machine intelligence into a public turning point. In 2012, Curiosity lands on Mars and reminds the world that long-horizon engineering still has geopolitical and scientific force. In 2013, major work on CRISPR in mammalian cells signals that genome editing is moving from theory toward practical leverage. Every one of these moments comes from a different domain, yet together they reveal the same pattern. The center of gravity in modern power keeps drifting toward countries that can connect science, capital, regulation, and production without losing tempo. The United States remains in that leading innovation cluster through the whole period, but the path is never comfortable. China rises with relentless intensity in both industrial and innovation arenas. Japan and Germany keep proving how durable institutional quality can be. South Korea shows how concentrated national effort can outperform size assumptions. India keeps adding breadth and long-run potential. Mexico deepens its role inside continental production networks. France, the United Kingdom, and Canada preserve important research and industrial niches. Nothing in this environment allows complacency. Leadership is a moving target, and every year rewrites the cost of standing still. In 2014, Manufacturing United States launches a network strategy for advanced production capability, linking research institutions and industrial execution more tightly. In 2015, OpenAI is founded and accelerates frontier work in artificial intelligence. In 2016, Federal Aviation Administration Part 107 rules open a scalable framework for commercial drone operations, proving that regulation can either block innovation or shape it for responsible growth. In 2017, reusable launch systems cross another threshold when SpaceX completes a landmark booster reuse. In 2018, the approval of patisiran marks a decisive moment for small interfering ribonucleic acid therapeutics and the translation of long scientific effort into real treatment. By 2019, quantum supremacy experiments with Sycamore add another layer of strategic uncertainty. The horizon is no longer defined by a single technological frontier. It is defined by many frontiers arriving at once, each with its own talent bottlenecks, infrastructure demands, and policy risks. That is why the deeper contest is not only about who can produce more in one sector. The deeper contest is about who can keep building new capability while old capability is still under pressure. It is about endurance under overlap, when yesterday's industrial responsibilities and tomorrow's research bets demand resources at the same time. Then 2020 arrives, and the entire system is stress-tested by the pandemic. Supply chains strain, production lines are disrupted, and uncertainty moves faster than official plans. Yet innovation does not freeze. The first messenger ribonucleic acid coronavirus disease vaccine authorizations in the United States show how quickly science can convert into deployment when institutions, researchers, and manufacturing partners align under urgency. This moment does not erase fragility. It exposes it. But it also reveals a strategic truth. Resilience in modern industry depends on the capacity to transform knowledge into action before crisis windows close. The emotional core of this story is not triumphalism. It is persistence. The United States does not glide through these decades untouched. It absorbs shocks, misreads trends, corrects course, and keeps moving through waves of competition that grow sharper with time. Around it, competitors do not fade. They become stronger, smarter, and more ambitious. China scales with historic force. Japan and Germany defend high-precision industrial depth. South Korea keeps striking above its weight. India expands its strategic space. France, the United Kingdom, Canada, and Mexico continue shaping critical parts of the global system. This is not a story of one actor alone. It is a story of sustained pressure, where survival itself requires adaptation. What remains after the noise settles is a clearer definition of power in the early 21st century. Industrial strength still matters because physical production remains the backbone of transport, trade, and material life. But industrial strength without broader innovation capacity becomes brittle. Countries that endure are the ones that can design, test, finance, regulate, and scale across multiple domains at once. Through 2000 to 2020, the United States stays in that decisive group while carrying heavy industrial responsibility and confronting increasingly capable rivals. The lesson is hard and simple. In a world of overlapping technology waves, leadership belongs to those who can keep inventing while history is already in motion.